Good morning to all of you. I'm audible, Chaitanya?
Yes, sir, you are audible.
Okay, now you can start.
Okay, sir. Good morning, everyone. I welcome all the dignitaries and participants to this 5-day online faculty development program on application of econometrics for management research. This is jointly organized by IIITM Gwalior and AICTE Training and Learning Academy. Thank you for your kind patience.
Right.
Sir, can we start the lamp lighting ceremony?
Yes.
I invite Professor Rajendra Sahu, a director of IIITM Gwalior, for lamp lighting ceremony.
Right.
Thank you, sir. Please give us a minute. Sir, is the screen visible?
Yes, yes.
Okay. Please wait for a few minutes.
Yes.
So we have around 200 participants registered for this program from various engineering and management institutions all over India, which include faculties, corporate professionals, and research scholars also. We have people from fields of specialization, including commerce and management, economics, psychology, computer science, statistics, and law and politics. And the participants' experience ranges from fresher to 10 years. We have with us the coordinator of this program, Dr. Manoj Kumar Das. He's faculty of Department of Business Administration at our institute. He's also faculty coordinator of a Technology Innovation and Incubation Center. Sir, I invite you for the welcome speech.
Okay. Kuslinder, PPT मेरा से मेरा PPT. Good morning to all of you. Honorable Director Sir Rajendra Sahu sir, the participants, my faculty colleagues, and my friends who are on this FDP program. So first, I'd like to thank the IIITM Gwalior to allow me to apply this FDP program on econometrics for management research to AICT, and I would also like to thank to AICT to sponsor this program under the aegis of ATAL FDP scheme. So if you think as FDP is for concern, I've already organized 16 programs as on date in IIITM Gwalior, and econometrics is 6 times. This is the 7th one, which is sponsored through AICT, and all of the previous 6 were organized by self-sponsored program. Now, this is not new that we're organizing Econometrics for research first time. This is the seventh time we're organizing this FDP under my coordinatorship. So let me explain the brief about the program. Next. This program aims to provide the participants in financial markets with the technique necessary to undertake the time series empirical analysis. The program introduced and developed both univariate modeling techniques and multivariate methods, including those regression techniques for time series that seems to be particularly relevant to the financial area. The objective of this program is to provide an introduction to the participants about the subject of econometrics in both applied and finance. And it is aimed that at the end of the course, the participants should fearlessly be able to engage in empirical research by using econometrical analysis and tools. Next, please. Basically, there are three objectives in our program. First, to provide an insight into the managerial application of econometrics tools to the participants. At the end of the course, the participants should be comfortable able to apply econometric tools in their empirical research work. And the program is also useful to understand econometrics forecasting techniques in the management research areas specifically. Next, please. Yes, the 5-day program is just like that. Today, we'll discuss about regression modeling through OLS method, then blue properties, that is best linear unbiased estimators. Then we have we'll talk about multicollinearity, heterogeneity, and autocorrelation. Then we'll discuss about the time series modeling by starting through ARIMA, starting with stationary testing, ARIMA, VAR, then by BECM, vector error correction model, granular causality, and co-integrations. Then we'll discuss about advanced econometric modeling through dummy variable models, that is logit model, probit model, and lag models. And at the last, in 5th day, we'll discuss about panel regression model by analyzing the fixed effect and random effects models. So basically, this program is divided into 3 parts. First, to talk about OLS. Second, talk about properties of OLS. Third, to talk about how to test how to do the forecasting through univariate model, hybrid model, and multivariate model through ARIMA. Then VAR, BCM, co-integration, granular causality. Then we'll discuss about panel regression model, that is called fixed effect, random effect. And at last, we'll discuss about some advanced econometric modeling that can use in the marketing and other research also, that is called dummy variable model, logit model, probit model, and lag models. So, as you know, there are 3 types of section data. One is cross-section, time series panel. And we have to try to cover all the modeling through cross-section. First 2 days. Next 2 days, we'll talk about time series, and last day, we'll talk about panel regression. That is the overview of the contents that we're going to be covered in this FDP program. Next, please. Now, I'm analyzing about our participants. If you see, there are basically the 6 disciplines people have applied: business analytics, economics, finance, HRM, marketing, and statistics. If you see, the most of the participants are finance, and the group is 0 to 5. The 25 participants from assistant professor, we have divided into different stream, assistant professor. You see, the most of the participants are the fresher. They are in assistant professor stage, and they are in the finance stage. It means out of 88 participants are from the finance background, and next followed by the economics, next followed by the HRM, and marketing, we are having 35 students. So what is the conclusion from this analysis? That yes, econometrics modeling is applied. It is a popular tool in all research areas, whether it is HR, finance, marketing, or it is operation. And you will see that if you go to experience wise, we have seen the ranges from 0 to more than 15 years we are also having. Some are professors, some are assistant professor, some assistant professor. There are 188 institutes are participating in this institute for all over India. Generally, there are 200 participants. Out of 200 participants, when we analyze, we have seen that there are 188 institutes are participating in this program. And you see that finance are the major one, the 25 assistant professor having 0 to 5, they are participating, followed by economics. And if you see that professor wise also, we are having 10 professors participating from this program. And if you see assistant professor also, there are 35 assistant professors participating, and others are assistant professors. Please, next, please. You see if you analyze the participant from, we have seen all of the country, whether it is Pondicherry, Andhra Pradesh, Maharashtra, and most participants are from Uttar Pradesh, 30 participants are from UP. And if you see the Indian map, all the parts of the country has been, they have joined now together. There is a Gujarat, it means east to west, south to north, the participants are having. So there is a very good platform that you can interact ourselves and create a research network, because it is not concentrated only one state. It's very interesting to see that our participants are from all over the India, and I thanks to AICT for taking this type of effort, that it means one institute can organize such an event where all the types of institute, all the types of faculty, and all types of the disciplines are participating in one common platform, thanks to AICT. Now, if you go the district-wise, we have seen that all part of maximum district we have covered through this program, whether it is Jammu Kashmir, whether it is Odisha, whether it is Gujarat, whether it is Maharashtra. If you see, it means all part of the country, all parts of participants from all over the country are participating. So I'm really, an institute feel proud that we are organizing such an event where most of the participants are from different parts of the country. Next, please. And if you see that university-wise, maximum participants from Chandigarh University, followed by Algaba University, we have Indore Institute, we have Manipal Institute. So 188 blocks are there where the students are participant, faculty are participation, and most of them, three institutes where the major participants are there are Chandigarh University, Algaba University. Now see, if there are 188 blocks are there, it means I'm really, I can say that the participants from all over the country are participating. So there are 188 blocks, means 188 institutes are participating in this program. Next, please. And if you analyze experience-wise, analytic-wise, you see that majority of the participants are finance background, followed by economics. And if you see the experience is concerned, and most of that are the associate professor, assistant professor. And interestingly, we say that some research scholars are also participating. There are 55 research scholars from all over India are participating. They are from IIMs, IIT, and IIITs, and NITs. Next, please. So this is the, again, I talk about the designation-wise. We have a professors, we are having managers, we have research scholars, we have industry participants, we are having trainee, you are having visiting faculty, we are having vocational institute also participating. So I thanks to all the participants to choose our program as one of their destinations for the career. Next, please. I thank the peer group expert. We have an expert from AICT who will be regularly, they will be surprised visiting in this program at any point of time. They will check the quality of the program. They will check the quality of the presentation. I thank to Sanjay MG from Encore Management Service Private Limited and the coordinator from Akshay Urja Abhijan is appointed by AICT to as a peer group experts. He will maybe ask some questions in between to take the feedback for the program. So I request Professor Mr. Sanjay MG, please participate in this program throughout the day, throughout all the 5-day program. And if you have any problem in between, kindly tell us. We will try to improve our side. And I thanks to my resource person. I'll start from Rajendra Sahu sir, Director of AAA Gwalior. Then we are having Arni Banik sir, Director of IMA Calcutta. We are having CP Gupta sir, Professor Delhi University. We have Professor Sudhakar Patra sir, Professor from Manampur University. Rajesh Chavan, Professor of Finance and Accounts from IMT Ghaziabad. Rajay Kumar, Associate Professor from AAA Gwalior. Dr. Vishal Vyas, Associate Professor from AAA Gwalior. Dr. Manoj Das, Dr. Mutinjay Swami from Manampur University, Associate Professor. And Professor Joshna Sahu is from also Manampur University, Associate Professor. What is mandatory from this course? This is being a coordinator of this program. This is my responsibility to explain in brief. So 80% attendance is mandatory for certificates. Every day we are having a test series. After 3 o'clock, we'll give you a login. I will provide a Google form questionnaire where there is 30 questions will be there. You have to participate, and that will be your attendance. So those will be, it means you have to test yourself, what are the learning from the day. You can also test yourself whether you have, how much you improve through the test series. And we are having a final test on 12th of October 2021. So it means 80% attendance. You have to participate in every test series. And to qualify this program, you have to secure at least 60% of the score in this program. Then only AICT will provide the certificates to you. Thank you very much. I request Chaitanya, please continue. Thank you very much.
Thank you, sir, for the introduction and detailed description of the program. I now invite Professor Rajendra Sahu, sir, Director of IIITM Gwalior, to kindly share his views on econometric research and management.
Kindly introduce Chaitanya. Chaitanya?
Yes, sir.
Can
So
you
please
introduce
give me a
the
break.
research person? Yeah.
Yes, sir.
Right, there you go.
Sir, I hope the screen is visible.
Yeah, visible.
Professor Rajendra Sahu sir has earned his PhD from IIT Kharagpur after completing master's degree in management and engineering. He is former director at IIIT Basair, Andhra Pradesh for 2 terms. He has more than 30 years of teaching, research and consulting experience. He is associated with various national and international consulting projects, editorial board of 8 international journals. He has guided 10 PhD scholars and published more than 100 research articles. He has received numerous awards, including the prestigious Dr. APJ Kalam Gold Medal Award in 2015 as a Lifetime Achievement Award to distinguished and meritorious Indian personalities for outstanding achievements in the field of education and research. Sir, I now invite you to kindly share your views on econometric research and management.
Good morning, everybody. I think econometric research or research per se is something that keeps us alive. Why I say it keeps us alive? Between all races of animals, the humans have evolved to dominate the earth. You see, others are becoming extinct, others are becoming less in number. But this is the only organism which is constantly growing. And what is the secret of this growth? Or how are we able to live or outpace others? If we analyze, we are able to live better. With time, we are able to live better. How are we able to live better? Living better is that we get new sources of information, new sources of knowledge, information which gets converted to knowledge. And this new source of knowledge is the key to our success. So knowledge per se is a necessity. So we pass on this knowledge to the younger generation. And it is said the younger generation develops on this knowledge and further increments this knowledge. Hence, the younger generation is said to be more knowledgeable than we. So only way to remain successful is to have a gain on knowledge and apply this knowledge for better living. What we call is skill development. Like if you have a doctor, the doctor earns his knowledge and finally he is given a degree. He gets a dual degree, a doctor gets a dual degree, MB and BS. But then we go to a doctor because he can take care of us, because he has the art of use of this knowledge for betterment of his patients. Nobody goes to a doctor because he has a degree. He goes to a doctor because he can take care of us. So knowledge becomes a paramount for all developments, all success, living. And research is discovery of this new knowledge. Many of the facts that we know, we might be acquainted with them and we do not analyze the rules, regulations, or the relationships that govern the system. So maybe that we would like to learn more about the system. Why to know more about the system? When we understand the system, we become the master of the system. We can play with the system. We can analyze the system. So as research is usually a novel development, it follows certain scientific steps, because these steps are the key to discovery of the new knowledge. The first step in research becomes one must have the standard or the structured knowledge about the system that he would like to study and analyze. System is a big concept. Wherever we would like to put a boundary to this system, because systems are subsystems of bigger systems. So we need to focus. Sometimes we study macro systems, sometimes we study micro systems, sometimes we study nano systems. So systems is where our focus of study is, remember. And system has to be isolated from the environment, because system is where our focus is, environment is which affects the system. And through interactions of the system behavior is communicated to the environment. It's very important to analyze. So we study the system and a deep knowledge of the system, and we see that there are certain things that need to be further discovered, further understood, or there are certain problems that arise which needs to be taken care of. So we can only take care of a system when we understand from where it emanates from. A doctor does not teach a patient for the temperature, but it treats a patient for the cause of the temperature. Because temperature is any rise of metabolic activity. Somebody has a 100-meter sprint or even climbing the stairs. So when you spend more than normal energy, your body temperature rises. But if this is controllable, then you don't take much action. If it is not controllable, it is coming from a source that we cannot take control. There the problem lies. So we need to find out the cause, from where it is coming. Where is the abnormal activity of the cells taking place? Is it that this abnormal activity is a natural process which will die out naturally within a manageable time without damaging the body? Then it's okay. But if it is not, then we need to take interventions to do that. Similarly is research. Similarly is the system. So in the system, the understanding of the system is the most important part. Where we see our problem or where we want to further enhance our understanding and knowledge of the problem. So at this is the first step, what we call is the problem formulation. We need to formulate the problem. And this has to be explicitly done as a problem or a source of enhancement of our productivity or knowledge, whatever we can say. The next is, if it is a problem and it is a big problem, then many must have attempted to solve this problem. The people who have solved this problem or attempted to solve this problem. So what part of the problem they try to solve? How did they try to solve? What all methodologies they adopted to solve? What all data they took to solve? And what they got, most importantly, what they got. Their inferences, their findings. And if these findings become more so universal in nature, that means many find the same, then it becomes science. Science is universal. If I do, I get a result. You do, you also get the same result. Somebody else does, you get the result. But when we talk of the art, it is very, very customized. It's very, very customized. Somebody does, he does it differently. Somebody else does, will do it differently. So this is the art. When we look into music or things like that, even on a household, the cooking, the diet is very, very customized. This is the art. Some foods are more tastier by some than others. So automatically this is an art. Some doctors are good in treating certain diseases. So that is the art, that is the skill, which is very difficult to be communicated, structured. And that is where the professionalism lies. When we move above science to art, today is the days of computer where structured knowledge is given to the system, because the system is more controllable, more manageable, more productive, more accurate, more precise, more reliable. You use the words of quality and cost. Everything is there in a system. It does not have a monotony. It tries to treat everybody equally. irrespective of who you are. So you must understand the problem, then you must understand how people have attempted to solve this problem. And when this problem is solved, then it becomes a standard knowledge, science. If it is unstandard, debated, discussed, unexplored, is an area for research. And that part which is not fully understood becomes a potential area for research. Remember, as a researcher, we should have a sound knowledge of the structured knowledge of the system. Structured knowledge of the system, which is already accepted, understood. Nobody will credit us for having a study of the system. Study of the system has to be done earlier, much earlier. Now you have to focus on the problem of the study or observation is a very poor form of research. Very poor form. It's an initial form. Many times it's not considered as research. Then the next part comes, you must understand where is the area that need to be explored for research. What we call is research gap. From the past studies, we try to understand where is the state of research. And from the state of research, we understand what are the portion of research that are still unexplored or remain to be unexplored and still it is not accepted by all. Thereafter, we give to ourselves, depending our own strength, knowledge, time, resource, everything, we give ourselves certain work that we would like to undertake in research, what we call as the research objectives. Objectives are very objective, explicit. And that is where we give to ourselves that I would be undertaking this much for research. So this is where the objective is. Up to this, we are not credited. We are credited for what we do, how we do, and what we get. As I said, the most important part is that we must understand that we are trying to take control of a system. When we like to take control of a system, we must understand the system and the elements that make the system. Because system has subsystems. If we take the economy of a country, there may be various sectors. One sector may be education itself. And when we talk of education, education has, if you come down from education system of the globe to the nation, to the state, to the various ways we can analyze. I'm coming geographically connected systems. Each has their own rules and regulations. And each has their own ways of operating. So any system that we focus, because if we focus the institute as a system, or the university as a system, or the department as a system, so then the focus lies within that periphery. So this is very important, because here it determines what we call is what we want to observe and what we want to control. So if we want to control a system to be doing better, to be taking corrective measures when it goes out of control or into abnormal states, then we must determine what makes the system behavior. The system behavior is indigenous. It comes from the system. Remember this. My behavior comes from my own body and my mind. Of course, it is sometimes triggered by the environment situationally, but it comes from inside. This is what is to be understood. Similarly, a system behaves, a normal behavior and a behavior under a situation. So we must understand. But the behavior comes from the system, which it interacts with the environment. Now there are various entities. So, some of you are IT savvy can well understand. When we represent the system, we represent the system through the small elements that interact. The small elements, we call them as entities, and they interact with what we call it the relationships between these entities. So these ER diagrams we draw. Similarly, in any system, we would like to know what are the elements that constitute the system and what is the relationship between the elements. If they are non-interacting, then it doesn't form a system. They need to be interacting. And this interaction is most important part. It's not what an element does, but how it affects others and overall how the system is now behaving. Now this system behavior is what we call is latent data. What is data? Data is observation of system behavior. Now we observe the system very discreetly. System usually operate continuously, but we observe the system very discreetly. So maybe this is also very important. So now you have certain things which change with time, certain elements, certain states of the elements change with time, what we call them as variables. And which does not change appreciably. We put them at the system boundary. The system has a demarcation from the environment at the boundary. So these boundary elements are mostly called as constants. See that they don't change, but nothing is constant. Appreciably, we assume that they change less than the variables. And for a specific time under observation, they change very little. So within the time period of our observation, under consideration for the study, if they don't change much, we call them as constants. Now coming on to the variables, or variables are known by various names. You have a concept. Concept is an idea about the system. Then you have concept to constructs, which are multidimensional attributes, interdisciplinary, interacting. So you will get all this while you go through the study. I would like to make a broad of it. Now, when you have the system behavior, now the system behavior is coming from the variables or the elements that make. These elements are changing, dynamic in nature. A system which is, this dynamism is also an important factor for the study. You'll come to know. How much data should I collect? Should I collect a data for the situation, 1 month, 2 months, 1 year, 2 years, 100 years? An epidemic comes in 100 years. A depression comes, economic situations come in 100 years or 120 years. Most things were predictable that we will have an economic depression in the early part of the 21st century. So we were seeing that large economies were collapsing in certain point of time. Their development rates have come down. We saw asset bubbles coming in various parts of the globe. And still we are experiencing that some of the major countries may again go through it. You must be hearing that defaults have started coming in large economies like China. The energy sector, the real estate sector, because real estate sector is said to be the most non-productive sector in an economy. So as long as people think, as long as it helps in production of the other assets, services and goods, it's okay. When it does not, then it becomes a liability because nothing grows, but this is the only thing, everything depreciates, but land and building, we see that it continuously grows. How does it grow? It cannot grow forever. It has to, one of the principle of any system is that a system does not grow forever, except knowledge. Exception is a rule that deviates all rules. Remember this. Except knowledge, nothing grows forever. So everything has a limit to growth. So when these systems large systems start growing and they start stabilizing. And when stabilizing, and then as a cycle goes into, it leads to either growth or it has to fall. When it falls, it takes the economy. The asset bubbles are the last of an economy. Similarly, so we must understand the system variables. So these variables of the system, which changes its state dynamically, we need to understand how do they change and how do they affect. Some of the variables are under the control of the researcher. We say the researcher means people who like to intervene. A researcher can also be called as a manager, researcher can be called as an executive, researcher can be called as a worker, anybody. So when you now will like to control a variable, and if you can control the variable, like the RBI announces the interest rates, the base interest rates, the money market rates or the commercial rates may be determined differently, or the project rates may be determined differently. But in an economy, a standard rate can be regulated by the RBI. Of course, it can regulate through other parameters. It can regulate through money supply. It can regulate through focusing onto certain sectors and increasing money demand. So there can be supply and demand are the two forces. So whatever way you can make to change money demand, or you make ways to control money supply, you can also control interest rate, and you can directly control the interest rates also by intervening. So the variables which are under the control of the researcher are controllable variables. And there are many which does not depend on our control, because it becomes large entities. When you talk of, so let us say we are concerned about the petrol prices hiking. The resources are depleting and demands are rising, price is rising. But price rise, if we leave it to a market-driven price, so it will rise. It's very difficult to control. Certain things are not controllable. Of course, we can fix the price at a different level. That's a different thing. But it is not under our control. The certain factors are not under the control of the researcher. When we say researcher, because we are taking a study, we call it a researcher. So research, so one which is controllable, you call it as a independent variable or a dependent variable. Dependent is which depends on others. Independent is that one is able to change it. Now when you have, that is why we call it y is a function of xi. So this is most important part of it. And we determine xi's, and we determine the relationship between the xi's to determine y. So you will have various methodologies of data collection, as I said. What period of data you should collect? Normally a question comes in that many times we do not analyze what is the period of. Somebody takes a year's data, somebody takes a 2 years data, somebody takes a month's data, somebody takes a primary data, somebody takes a secondary data. We say secondary data should have its own quality of the data, because the data we take or the period of the data we take usually determines the system behavior. So if we have collected the data of only one phase of the behavior, then it will reflect that phase of the behavior. Like in an economic cycle, as I said, the data has to be 100 years, 120 years to have a cycle. But in a market situation, which is highly dynamic, changing, you might rely on a primary data because situation has changed. When we are modeling, remember, model is representation of the system. Now, when you are representing the system, Your assumption is that the system is same. When you would like to use a new data or a new observation or a new parameter. But the system has changed, that's difficult. So modeling is basically the representation of the relationships between the various entities or variables, what you call, or factors, whatever it is, or parameters, whatever way we try to say it, the relationship. This relationship is very important. Remember, data is useless. Why data is useless? Because nobody is interested in the data. Where are we interested? We are interested in representing the data in developing the model. But data may be useless because data is representation of the system behavior or which are the observations at a certain point of time. So they become, assuming a stable system, a system which is not changing much. You'll study them. How do you call a stable system? You have stationarity of the data, non-stationarity of the data. Can we model non-stationarity? Or we do not model non-stationarity because it's difficult and complex. The noises are too much into the system. Or the unexplained part of the behavior of the system is much more. So we convert this into a stationary data. For the ARIMA model, the AR and MA components are important. But the I, which is interlinking the both, is the most important part and first to be taken care. You have to remove this integration, differentiate it as many times of integration to make it a stationary data. Then only you can have your ARMA model sitting on it. So now when you are developing the system, it is a compromise between, remember, the model is a compromise usually between, because we cannot represent real life fully, some compromise has to be made. This we make it through assumptions in the model. Assumptions are built into the model. If these assumptions are valid, model can be used. I cannot use anything for anything. Each of these models have their own assumptions. Please look into the assumptions. If the assumptions are valid, model can be used. Or else the model cannot be used, you have to look for better models. And when we use a model, suppose we use a single factor to determine y is a function of x, only x, not x, there's only one factor, one independent factor, x. So it's very easy to explain. So simple models, normally socioeconomic systems are very complex. The concepts are very complex. So that is why we call them into constructs. So this, if we are using a single parameter and you are using a linearly dependent parameter, then it's very easy. However, whether this model is easy means it's easy to understand, easy to explain. Now when I have my accuracy sufficient, then I will use a simple SLR, simple linear regression model. But when I would like to have more accuracy of the system, I would like to take in other parameters. Now x becomes x1, x2, x3. How much? Where? Depends on what degree of accuracy that I want from the system. We'll study them. R square. And then what we get into the model is an average relationship. Remember this. Most of us do not understand that what model we got is a precise model, an exact model. No. We are getting an average relationship because each of the parameters are distributed. equally, normally, then the model is also having a normal behavior. It would also have its standard deviation. It would also have its own variances. They are inbuilt. Most of the time we do not understand. We understand that we can extrapolate, and we can extrapolate and get a point estimation. Now, simple to multiple to various regressions that you will be going through. And when we see large number of factors, and suppose you are having a multiple variable, then the assumption is that they are independent. Now, if they have a relationship among themselves, confounding relation, then we need to find out, and a way of clubbing these variables also had to be done. Sometimes we also try to use raw data, and this raw data we sometimes have a transformed data. Because by transforming a data, suppose an exponential data, if it is transformed to a logarithmic data, the data can behave to be used into simple models. So always a raw data is not used in its own form. And the data, if you have multiple variables, how do we bring them? Because normally many times we forget that they have to be brought to the same unit to be combined. You cannot get two different units to combine them. So you need to have parameters and weights for each to be combined. You will be studying, sometimes the data is not crisp, fuzzy data. Sometimes data is subjective. So the data and its amenable analysis is very important. If the data is coming from a high frequency data, low frequency data, the stock market data cannot be compared with an economic indicator data. Most of the data mining techniques that we use today are for high frequency data. Are the data integrated? Means one has a relationship with another system and follows the lead and lag models. When you go into Arima, you will see them. What is the order of each of them? That will determine the class of the model. So these are very important factors. In the integration also, you need to see whether it is following. And if we don't understand anything, we use what is called one of the best is the random walk models. The stock market follows. The stock market is the most difficult. Like today, they follow a algorithm-based models. And it is seen that people, those who develop these algorithms, they themselves fail. You must have heard these examples of unicorns of India itself. And you can take the examples from the initial days of the best models. They might get a award or a prize, but still their farms go broke. Understanding is one, and applying them into the real life scenario is another issue. So these are some of the major issues that you will be getting. And when you get large number of factors and you do not know what is important, what is less important, then we like to use what we call is a factor analysis. Identify the important factors that contributes to a level of accuracy, and then use these models. So model is basically a compromise of simplicity and accuracy. Given a choice, I would like to use a simple model. But if the accuracy of the model is low and not acceptable, then I would like to use a complex model. And the complexity of the model gradually increases. And today we use what is called the black box models. That means you don't understand anything and use them into a logic-based model, what is called the AI models. These AI models or artificial intelligence models tries to discover the relationship among itself. It has various nodes, what we call is these nodes are called as neurons. These neurons keeps learning, and it tries to determine the strength of the uh, relationship between the neurons. That is the most important part in the model. But we do not know. It keeps iterating, keeps iterating, keeps iterating. And since it has to be discovered from the system, if we take a small data, which may be biased, hence these are data intensive models. You cannot take 5, 10, 20, 100 data to use into a AI model. You must have thousands of data. And we don't say in thousands of the data, what we say is in terabytes of the data, gigabytes of the data to be used into these models. So the model learns from itself. But remember, the model, all model development depends on the same principle, whether it is a traditional model, whether it is an AI model. The model finally believes in reducing its errors. So that is the basic logic. So error reduction, whether it is a simple SLR or simple regression model, or it is an AI model, or it is any type of model, the basic thing is that we would like to see that it behaves or it emanates the behavior which has been initially put as an input. Now, once this is acceptable to us, we say the model is developed. Once the model is developed, data is of no use. Now, what do we do with this model? We try to play with this model. How do we play with this model? Because we wanted to control the system. So now we would like to say we have model means we have represented the system. Now we play with the model. Playing with the model is changing the parameters. Now when we see changing the parameters, we have an expected behavior. We try to see whether it is exhibiting those behaviors which we thought that it would behave. And then we also see how it is creating an intermittent behavior because it is related to many internal variables also, or subsectors, or subsystems, entities, how it is behaving. Because there are many intermittent variables through which the output moves through, and it affects each of these variables or each of these elements or each of these subsystems differently. So when we play with this model, we see this. This is what is called, what we call a half a decade before, is that these are called interactive learning environments. So we try to play and learn before we, because if we take a decision, the effect of a decision is visible later. Now in a model, we do that, assuming that the system to remain the same, that we play with the model, change, and take policy decisions. If I change this, what is going to happen? If I change this, what is going to happen? Independent policies, multiple policies, combinatory policies, and various levels of the policies to get a best system. So remember, each of these steps has to be judiciously be done. Firstly, what type of model I'm going to select, what type of data I will get, what is the expected initial outcome of the data. I must know my end before I start. If I don't know where I am going, what I am going to achieve, likely to achieve, I might go astray. So research has to remain directional. Yeah, we might get a new thought in between. This is why research is taken as a project. A project is where you understand some part of it and you don't understand some part of it. There is a risk involved. So the known part is that you follow the structured algorithm of conducting research. The unknown part of it is unknown. You will discover it at the end. You might get something which you thought, that may enforce your belief that what you thought was scientifically derived. Sometimes you might not get, but remember, research is not what you wanted to get, you got it. Or what you wanted to get, even if you don't get it, if you fail in research, it is also a research. But the research must follow the basic principles of research, where there's nothing called failing in research. It is trying to study, and what I have studied may be incomplete, and I need to further analyze. That's very important. And each of these steps has to be judiciously done. I know this workshop, which Professor Das, as a coordinator, has undertaken, is well designed, well planned, and econometric is as like economics, is not easy, because whatever you say, the antithesis of this is also true. Because there are large number of loops, what we as system people say, there are large number of loops in the system. Some loops may be stabilizing, some loops may be uncontrollable in a situation. Means within the framework of study of time, they will get stabilized over time, but that over time may be a longer period. Economics, and thereupon econometrics to solve such observation or such complex problems has to be dealt in very suitably and judiciously, so that our inferences or learning from the system becomes more complete, better. So I wish, I know, and I believe that the workshop will be very useful for most of us. What to do, when to do, where to do, how to do, which models to select, what type of data to take, what level of data to take, how do we measure data, because the data has to be an input to the model. If the model is not accepting, then you cannot. So, and model is a choice of the modeler. How much I understand. It's not that this is good or this is bad. The choice between good and bad, there is no choice. I'll always select the good. But many times suitability of the model for a particular purpose has to be ascertained. Why I have selected this, or why I want to select this. Whether I'll go for a secondary data, which is, if it's a reliable secondary data, quality data. Why should I go for a primary data? Many times people think that I would like to go and do some primary data collection is very difficult. Most of the times we think that we will do, and those who have really done primary data, they understand it's not easy. And sometimes it's not necessary. Nobody gives you a credit for getting a data. Nobody gives you a credit for developing a model. Suppose if I develop an AI model, some whatever AI model, I would not be credited for the model. What I will be credited for? Remember this, I will be credited for understanding that I understand the model. And I can customize the model. Vis-a-vis, I use a software which is already standardized. So if I use a software, I have to say, I'm using SAS so-and-so, SPSS so-and-so, version so-and-so. Because that accuracy, what is inbuilt into the software will come to you. So whether you like to develop a model, whether you like to programming a model, whether you like to customize it, whether you like to use a standard model, whether you like to use a hybrid model, taking features of one to the other, and what are the steps? If I have a hypothesis, which is very optional in a thesis, but sometimes it's a strong bias by the researcher. Before I go on to further research, I would like to test those hypotheses, whether they are true or they are not true. These are very important in research. Please, I know that the workshop is well designed and will take you through to the various stages and various methods, models, and is a wholesome. So I take this opportunity to thank the coordinator, the research persons, and also AICT, which in these corona times have tried to keep us learning and keep us updating. Thank you, everybody.
Thank you, sir. Chaitanya, please continue.
Thank you, sir,
Yes, sir.
for your enlightening speech on econometric research. I thank
Chaitanya, wait. Is there any questions related to session 1?
Yeah.
Dear participants, we'll take 2 or 3 questions.
Sir, this is Vani over here, sir. Am I audible?
Yeah, audible. Yes, you are
Sir,
audible.
Manoj sir, good morning, sir. The session was really good. Gave us a lot of inputs. Sir, I have a small query. Like you said, in the data, the frequency of data, you cannot take up a stock market data and compare with the macroeconomic variable data. Normally, we take a log and do it up, no, sir? Is it right, or is there any other way to do it up? Because it's annual data, quarterly data, you start comparing with the daily data or something like that. So we normally take a log and do it up. So how far the results are accurate, sir? So when we do it up for a research papers or something like that.
The log data is basically for exponential data, which can be, usually what we do is that we take a raw data. Raw data is good. But if raw data, if you now see the raw data is integrated for a macro analysis, then you have to differentiate it. For a data which is showing a transformational, you would like to transform a data. Suppose I would like to say y is equal to ax plus b. You would like to use a simple raw data. You are not using a transform data. Y is equal to x to the power a or a to the power x, whatever way you put it. Then you would like to use a logarithmic model. When you transform this, log x now becomes linear to log y. Are you getting me?
Yes, sir. Yes, sir. Yes, sir. I'm
Now
following up.
when-
I'm making a note.
Yeah, when you are having an exponential model, you would like to convert it into a linear model. You would like to use a transform data. So data transformation depends on the model. So first you
Okay.
select your model, then you have no choice with the data. But if you would like to use a simplified model with a transform data, that's okay. Because sometimes we try to take in stock market, as we said, we try to, because this is the most important model in stock market becomes the RW model, random walk model.
Correct, correct,
I
sir.
think
Correct,
you
sir.
must have heard. Because
Yes, sir.
all
Yes, sir.
models have failed here. So what we try to say is that we only look into the current state
Hmm.
and take a decision of the next state. How do we take a decision of the next state? So we look into the state changes. Agar if it has come to this state, what type of behavior it has done previously? So normally in finance, we say the data is useless, very useless. You do not take the past data, because if you take a past data, everybody will be doing the same. Everybody takes the past data. So one who has more knowledge than the other can only exploit arbitrage in this market. Are you getting me?
Yes, sir. Yes, sir. I'm with
So
you.
we don't look into what is the value of the data. We look into what is the direction of the data in financial markets.
Correct.
If it is going to go up, suppose it is going to go up, means what? It is going to become more valuable, then I will buy today. I will buy today because it is becoming more valuable and I will take arbitrage. When I sell it tomorrow, I'll get a profit.
Correct.
But and if it becomes, now suppose it increases by 2 rupees, let us say. Vis-a-vis it increases by 5 rupees. What will be my decision? My decision will be same, because whether it is 2 rupees or it is 5 rupees, I am getting a profit. Are you getting me?
Yes, sir.
So
Yes,
I
sir.
will
Yes, sir.
take a decision to buy it because it is going to go up, not how much up. So
Okay.
if it is going to go up, I will take a buy strategy. If you would like to come down, I like to take a sell strategy. If you would like to move sideways, I will have a hold strategy. I'll have a hold strategy because it's not going to gain anything out of it. I must hold on because arbitrage will get only when you would like to buy and sell, when you transact.
Okay.
Okay. So transform data, please see that transform data is for the suitability of the model. Like ARIMA model, we normally use a ARMA model, ARMA. So you have to
Correct.
use a stationary data. That is also a transform data.
Correct.
But how much degrees of transformation you will do? So you are using the del XI, not you are using XI, del XI. Only the
Del
change
XI.
that you are making. Are you getting me? That also is
Yes,
a
sir.
transform data. So you cannot simply say looking into the data that this is to be done. It has to be further analyzed. The first thing that we do is that we try to analyze the data before we try to model the data.
Correct.
Model using the data, I would say. So that is most important. You must analyze the data. If it is there, you have no choice. So you have to analyze the data, whether you like to use a raw data, transform data, confound data, what factors, what all. This is why we use more of black box here. That means in stock market, we take the past to determine the present. Means that means what that is the trend of the data. What is the cycle of the data? So if it is moved to this level, may come down. Mostly it is 90% of the time has come down. But that risk of 10% is ours. Okay, thank you.
Any
Okay, sir. Thank you, sir.
any question from any question? So before I complete, I will just explain about the 15th concept that we are planning in this concept. In next class, we'll discuss about the regression modeling. It means we'll have a dependent variable y related to some of a function of x1, x2, x3, x4. So develop a econometrics modeling on that through views. Then we'll go for the blue property that is called best linear unbiased estimator. It means the modeling what you have estimated, whether it is a best linear unbiased or not. We'll check the multicollinearity, we check the heterogeneity, we check the autocorrelation. Multicollinearity means whether there is a relation between the independent variables correlated or not. Autocorrelation means whether errors are correlated or not. And distribution, we go for the homogeneity. Once we have done all the tests, then we'll go for the stationary checking, whether that individual test is there or not. Once you go to stationary checking, then go for ARIMA model, that is autoregressive model. Then moving average means error, whether correlated or not. Then go for ARIMA, the autoregressive integrated moving average. Once it is ARIMA model, then you go for the whether after modeling, if you see there is a clustering in the errors, then go for arch model. And once you go to arch model, if you want to improve the model, we go for the Gratz model. And then you will find out whether the relation between cause and effect is there or not in the variable. We go for granular causality. And if you want to know whether the after the granular causality, if you say improve the model, we have a VAR model, better autoregressive model. And if there is error is there, then you have to apply vector error correction model. Once you apply VAR, vector error correction model, then you will find out the final estimation model, which is used for the forecasting. But sometimes you're also using panel data, where you find out the fixed effect within the variable, within the sector, and the random effects. And which is the best effect that we go for the ground test, VG test. And then we'll complete our sessions. It means starts with modeling, ends with so first 2 days will cross section, next 2 days will be time series, and last day will be panel data. So each class there is an objective. Okay, so this interlinkage class. So if you miss one class, then it means next class it is very, very difficult for you. So I request all the participants kindly attend the sessions. So the next session will be in 11:30. I request all of you please be assembled at 11:15. Okay, and for that I request all of you please install eViews also, because sometimes the resource person also asks to demonstrate. So there are 3 software required for the econometrics. One is eViews, then second is called SAS, Stata. That is for, and this 2 is very necessary for all of you. Please download the trial version. And if you have any query related to the class or data set or the material, I've already distributed 10 books and 15 research papers in that WhatsApp group. Please go through it. And I hope you will enjoy this session, all of the session. Like today's session is very good, it's interesting. We give some insight, what to do, when to do, how to do, where to do, and from whom to do. That part is already clear. So that is Thanks to our director sir, for Rajendra Sahu sir, who have taken his valuable time and spent his valuable time for providing insight to all the participants. I required constantly guidance throughout the session, sir. And now I request Chaitanya Singh, our scholar, please say a vote of thanks.
Thank you, sir.
Sir, 1 minute.
Sir, am I audible?
Attendance link
Yeah,
is
you are
not
audible.
there.
Which one? What, ma'am?
Attendance link.
Already you have said in the chat box. Please go to the chat box. Okay. It will be remain till 11 o'clock. Okay. Please go to see the chat box.
Small request, whatever link you have presented in the WebEx, it's not working, it's not getting open. We are all teachers, sir. We are all research scholars. We are actually distracted because of the attendance and all. We are here to listen to the faculty and ask many questions. Well, I am more interested in the sessions than the attendance, but this attendance issue has been bothering me since last half an hour.
No, not listen, madam. It is listen. I don't. This is the IICT requirement. The 80% attendance I should submit because they are also wondering in the system also. Okay.
We agree that we are ready to it, but whatever link it is being displayed, that is not working. I've been messaging also.
We will also have a Santoshi Madam ji. Okay, don't worry about attendance. Okay, we have a different formula also. Okay, please focus on the class.
Sir, a choti si baat hai, because anyways we are attending this WebEx meeting. People who are already logging in can be taken as the attendance. We don't have to be assertive.
Santoshi Madam, don't. If you have any problem, kindly you write and post in the WhatsApp. Okay, individually will solve your problem. So don't, please focus on the class. Don't think about attendance.
Yes.
Okay.
Thank you so much.
It is a part and parcel of this program. That's why we are focusing. Otherwise, just focus on the class. Okay. Okay. Now, Chaitanya, please continue.
Yes, sir. First of all, I want to thank all the participants for joining us for this program and for their patience. Special thanks to Professor Rajendra Sahu sir, our director, Dr. Manoj Das, our coordinator, and AICTE for organizing this fruitful program. I also thank all the esteemed speakers of our scheduled sessions. I hope that all these sessions add value to the participants' knowledge. Now, as told by sir, we will take a short break, and I request all the participants to kindly reassemble, join the program by 11:15 a.m. We have a next session scheduled for 11:30 a.m., which will be delivered by Professor Arindam Banik on econometric modeling and linear regression model. So I request all the participants to go for a break and kindly come back by 11:15 a.m. Thank you.
Thank you.
Sir, how mark the attendance? I'm not able to get it.